84. The equilibrium constant Kc for this reaction is 5.0 at a given temperature, and then they give us this equation, which I wrote down here. Then we have letter B. Maintaining the same temperature, additional H2 was added to the system, and some water vapor was removed by drying. A new equilibrium mixture was thereby established containing 0.40 moles of CO, 0.30 moles of the water vapor, and 1.2 moles of H2 in a liter. How many moles of CO2 were in the new equilibrium mixture? And then the rest of it says we have to compare this with the quantity in part A. Okay, so this is part B. So we've done a couple of things in part A that's going to transfer over to this question. So the first thing is that we found out what the Kc expression already was. If you want to find out how we got this, go back to the first part, because we're going to be using this same Kc expression, because it's the same equation. Now, they're still giving us equilibrium values, right? They say a new equilibrium mixture. So I have equilibrium values. And let's see what they give me. So they said a new equilibrium mixture, we have 0.4 moles of CO. So that's this, right? So I have now 0.4 moles. And I have 0.3 moles of the water vapor. This is H2O, that's water. Vapor is just gas. So I have 0.30 moles. And then I have 1.2 moles of H2. Okie dokie. And now they want to know how many moles of CO2. So I need to find out what this is. Basically, it was the same thing as letter A. Okay, so we have all equilibrium values. We're solving for X. We're going to plug these in. But remember, guys, these brackets means concentration. And concentration means molarity, not moles. So just remember, the molarity formula is molarity equals moles, which is what they gave us, divided by liters. So did they tell us how many liters there were? Well, yeah, they were very nice. They said that we had all of this amount in a liter, a single liter. That means that we only had 1 liter. But if they said that we had, 2 liters, you would have to take all these numbers and divide it by 2. But since anything divided by 1 is itself, I know that these are now just the molarity values. So I can get rid of all the moles. And actually, what I'm going to do, just to make it a little bit easier, I'm just going to say on the bottom that these would be the same as moles and molarity. So I have 0.30 molarity, and maybe I'll just stick this a little bit back, because technically this was 0 for sig figs, and then we have 1.2 molarity. Okay, so 1.2 going right in here. This is our X value. This is 0.40, and then this is 0.30, and we're just solving for the CO2. We know that we have the Kc, that's 5.0. So let's just plug it all in. 5.0 equals, seems like we got X, and let me just make this a little bit better. There we go. X times 1.2. And then on the bottom, we're going to times it by 0.4. And then times that by 0.3. Whoop. That should be in blue, just to show you the different colors. Okay. Simple cross multiplication, right? These are going to be all multiplied, and these are going to be multiplied. So let's just do that. Calculate out. 5 times 0.4 times 0.3. I get 0.6 equals 1.2x. I want to get x by itself. It's being multiplied by 1.2, so I'll just divide by 1.2 on both sides, and I get an x value. Okay, so 0.6 divided by 1.2, I get 0.5. Okay, and remember, these were molarity, and that's of CO2. So if I now know that I have a molarity of 0.5, technically it should be 0 molarity because of sig figs, what would be the moles? Yeah, it would be the same, right? So in this case, we have 0. So maybe I'll just say that this is equal to 0.50 moles of CO2. Okay, so that's the first part to this question. Now it says compare this answer, the 0.5 moles, with the quantity in part A. So just as a recap, in part A, there was 0.33 moles of CO2. And now we have, and maybe if I could just like copy and paste this, now we have an amount of 0.5 moles, right? So what happened? In part A, it went from 0.33 moles of CO2, and it looks like we increased, right? To go from 0.3 down to 0.5, there was an increase in CO2. Okay, now it says, discuss whether the second value is reasonable. Should there have been an increase in CO2 according to what they said? Well, let's see. What happened? Additional H2 was added to the system and some water vapor was removed by drying. And then a new equilibrium value was established. So, this is Le Chatelier's principle. We have to figure out what's going on. Additional H2 was added. Here is the H2. We added that, right? So, according to Le Chatelier's, if you increase a concentration of something, you have way too much. You need to get rid of it. So what's going to happen? Well, the shift is going to go away from where you added. If I have too much H2, I need to shift to this side. And because of that shift, that's how you're going to get the H2 to come down. So let's see, does this increase make any sense? What's actually going to happen to the CO2 and the H2 if we're predominantly going in the reverse direction? These are going to drop and these are going to rise. So should we have seen an increase in CO2? No, right? We should have seen a decrease. So is this reasonable? No, this should have not happened. So not reasonable. Because according to Le Chatelier's, we should have seen a decrease in this if we were predominantly going to the reverse direction. Now it says, explain how it is possible for the water vapor concentration to be the same in the two equilibrium solutions, even though some water vapor was removed before the second equilibrium was established. Well, this was basically the same exact idea that we just started here, right? If you add H2, you will shift to the left. And what's going to happen with H2? Oh, yeah, it's going to rise. So that's how it's possible to, gain it back. It said that some water vapor was removed by drying, but since we're predominantly going in the reverse direction, you're going to increase your H2O. And that's why your water vapor is going to be the same. So hopefully that makes sense. Thank you so much for viewing the video. If you want to subscribe, you can. But if not, that's okay too. I appreciate all you guys. I hope you guys are learning out there. Let me know in the comments. Love talking to you guys, and I will see you all in later lessons. Have an awesome day. Bye-bye.